Hi everyone, hope you are all well. My name is Riley and I will be your host for this webinar. Before we get started, I would just like to go over some notification settings. So if you just want to go to your settings, which is the cog symbol, it should be in the bottom right hand corner, or if you're on mobile, it might be in the session menu. And once you find the notification settings, just untick all the boxes, and that will make sure that you don't receive any sounds, notifications during the session, which might be a little bit annoying. And just an acknowledgement of country. In the spirit of reconciliation, the Engineering Institute of Technology acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Can I just make sure that everyone can hear me okay? Imtiaz, can you hear me okay?
Yes, I can hear you nice and clear.
Thanks, Imtiaz. So the topic for today's webinar is enabling digital transformation of industry with AI and big data. So this will be presented by Dr. Imtiaz Madni, who is in the session with us now. I'll just go through some quick questions and frequently asked questions, and that is everyone will receive a copy of the PDF slides and a link to the video recording within the next 2 business days by email. So I will send that out likely tomorrow. And we also provide a free digital certificate of attendance for live attendees for these webinars. There will be a link or a QR code provided at the end of the session, and it just links to a short form or survey that you need to complete in order to receive one. And about EIT, so we're a specialist engineering education provider. So we deliver a range of courses, starting from short 3-month courses like professional development, which we call professional certificates. And we also have courses in the VET sector, such as diplomas and advanced diplomas. And we also have a range of qualifications in the higher education space, such as undergraduate and graduate certificates, bachelor's and master's degrees, and more recently a Doctor of Engineering. Our courses are regularly updated to stay relevant to the industry, and we also have vocational and higher education degrees registered and accredited by the Australian government. We also have some courses that are internationally recognised under the Dublin, Sydney and Washington Accord with Engineers Australia. We have industry experienced lecturers, so not only those who are involved in academia, but those who actually have real world experience and can apply that to their teaching, such as Dr. Imtiaz himself in the session today. He's a working engineer. And we have many other lecturers that work for us, just like Imtiaz. We have a unique delivery model, which includes a range of live and interactive webinars, similar to what we're doing today, an international pool of expert lecturers, dedicated learning support, and state-of-the-art technologies, such as workshops, remote labs, and simulation software. So the agenda for today, I've introduced the session and I'll hand over shortly to Dr. Imtiaz. But what we'll be going through is what is industrial AI, enterprise AI applications, international standards in enabling smart manufacturing, SC42 ecosystem approach, and finally we'll conclude the session with a short Q&A, and I'll also provide that link attendance that I mentioned earlier. So I'll now hand over to Dr. Imtiaz. Thank you very much for coming today, and I'll now hand over to you. Thank you.
Thank you, Riley. Thank you very much. It's a pleasure for me. Hello, everyone. So my name is Imtiaz Madni. I am currently living in Perth, Western Australia. I completed my PhD degree in electrical and electronics engineering from the University of Western Australia a few years ago. Worked in academia for a while, and I've been engaged with EIT, the Engineering Institute of Technology, since 4 years now. Currently, I work full-time as a lead engineer in the industry. So mostly focusing on the innovative technologies and state-of-the-art technology. So because there's a lot of happening in terms of digital transformation, in terms of energy transformation. So it is exciting times, and Australia is trying to stay ahead in the game. So there are a lot of opportunities in these advanced technologies. So I'm lucky to be here at the right time, and I've got a really good team and also some support from seniors. So yeah, so before moving to Australia, I was in China. I worked there for 2 years in research sector. I was working for Chinese Academy of Sciences, and before that I was in Japan for a few months, and then before that I was in South Korea. I got my master's actually from South Korea, and before that I was in Pakistan. I got my bachelor's from Pakistan, and before that I was in Middle East. So I've been living in several different places, not just I have a diverse technical background, but also have a diverse cultural background. So happy to be here today. Hopefully, I will be able to provide you some more knowledge about the topic. I won't say I will provide you all the knowledge, because obviously we have a short time for this webinar. So I wanted to keep it relatively simpler for all the audience. So considering that not everyone is from the same technical background, or some of you might be just starting their student life or their um, university life. So this webinar will provide you a basic overview about digital transformation in industry, which is happening all over the world. So um, we were talking about Industry 4, now we are talking about Industry 5. So things are happening really fast. So hopefully it will give you a good overview. So we will be discussing how these new technologies like artificial intelligence and big data are helping us in this transformation. So first of all, what is industrial um, artificial intelligence? So as the name says, it's artificial intelligence, and similar to automation, what we have been using in industry. The whole purpose is to have less reliance on the humans and reduce the human interaction, because sometimes it's not all about saving costs, but also about saving human lives. There can be some situations or conditions where humans cannot perform well, and there can be some hazardous conditions to where we do not want humans to work. So this uh, with automation, we can achieve better performance and we can reduce the hazards. So artificial intelligence or AI just refers to those computer science techniques and technologies that allow the software to exhibit these smarts, or in other words, to do things that seem like human. So it means they just imitate human actions. So this can include things like making decisions, recognizing objects, or understanding speech. So it's a very broad term, as you can imagine. For different industry, it may mean different tasks, right? So in general, there are several benefits for AI. It's not only for industrial applications, as we know, it is used in several other fields. So in general, the advantages are in terms of data, like internet and social media data sources. These days, we see there is wide application of data in our social interactions, in our daily life. But in terms of industrial application, obviously we have proliferation of network sensors and connected devices. So data is very important in industrial application as well. So data, I often use this word that data is the backbone of industrial automation. So without data, we can't achieve any automation. And similarly, in terms of hardware, we have faster CPUs and GPUs. By using AI, and in industry, we can have intelligent devices and systems and robotics. So these can work at a much faster pace and much more accurately. So this is a great advantage of using AI and these intelligent devices. In terms of software, so in AI, mostly we use machine learning. So machine learning is all about artificial intelligence. So we train the machines to perform certain tasks so that they can achieve that kind of intelligence. So in industry, obviously, it can be very, very useful because we can have active learning for these machines, and then they can perform on their own. We can run some simulation of the processes before actually installing any infrastructure, so we can understand how will the process behave and what are the challenges and how we can overcome them. So simulation is widely being used these days. So it's all because we have such software and such algorithms based on AI, so they can provide us insight into what the system will look like. And that digital twinning is a big part of that, and it is becoming very popular these days. Mostly larger organizations, they are acquiring such digital twins for their systems. So question is, how does AI relate to the machine learning and big data? So we often hear these words, machine learning and big data and artificial intelligence. So how do they relate? So strictly speaking, machine learning is artificial intelligence. So we can't achieve artificial intelligence without machine learning. So machine learning refers to a set of techniques that allow us to create these AI software by training that software with data to display some desired intelligent behavior, right? So because you can't uh, achieve any intelligence, even humans, they need some kind of learning. Like when we are born, we don't have any intelligence. So with the passage of time, we observe and learn, and then there are some learning platforms. Our parents and the people around us, they are kind of learning uh, platforms, right? So similarly, for achieving artificial intelligence, we need to train those machines and those devices. So that is done by machine learning. So machine learning is very important for AI, and that's how it relates to AI, because we can't achieve AI without machine learning. So machine learning, while it's the only way to build an artificial intelligence system, for all practical purposes, we sometimes use these two words interchangeably. Sometimes we call it machine learning, sometimes we say artificial intelligence, but it's obviously the same thing. All the interesting activity in AI is in machine learning. So once you're training the machine and you're telling it basically what does everything mean, and then it can go on and make its own decisions based on that learning. So how does this relate to big data? Then for machine learning, you need some information, some statistics, some uh, um, insight into the system, right? So you need historical behaviors and trends. So that all is in the form of data. So data is used to train the machines, and the more you have it, the better, right? So similarly, we can use big data to make decisions for ourselves as well, or means decisions which we need to make. We use those data to do some predictive analytics. So predictive analytics is also becoming very popular in industry, because now we have systems which can generate a lot of data. Every device can generate data, so we have access to the data, which can be very helpful in making these decisions and analysis that we can use to perform better. And also in maintenance systems, we use this predictive analysis uh, to predict when will we need to take an action before something happens, right? So predictive maintenance is very useful because it helps us reduce any faults and failures, so we can make decisions before something bad happens. So it reduces costs, reduces hazards, and makes the system efficient. So data, then again, it's very important in terms of machine learning, and machine learning actually is the backbone of AI. So all that is interrelated. And then we hear a lot about in Internet of Things these days. What does it actually mean? So things in Internet of Things is actually those devices, those smart and intelligent devices can communicate and can make decisions. So basically, it is an intelligent system. So these things are embedded with such electronics, software, sensors, and networks, which enables these objects to collect and exchange data. So communication for these machines is in the form of data. So unlike humans, we can speak. Our communication is in the form of waves, sometimes in the form of data. But for machines, obviously, data is everything, because they can only talk in terms of data. So for enterprises whose operations involve the physical world, the industrial Internet of Things is an increasingly important source of insight into the status, location, and performance of enterprise assets. Right. So different industries may have different requirements. So these days we have remote control and remote monitoring systems. Like big enterprises, they might have several sites in the remote areas, so they can monitor everything and control everything from their control centers somewhere in the downtown in city. So that can provide all the information about their system, what is going on, how is each device performing, because those devices are smart, they can talk and they can send information. So that is very useful. So that forms industrial Internet of Things. So in industry, obviously, we have hundreds or thousands of such devices. So that's why industrial Internet of Things is slightly different from the Internet of Things, which we see all around us in our houses, like we have smart homes. So industrial application will obviously contain better devices that can bear or tolerate the harsh conditions in an industrial environment and still be able to communicate and provide useful information, and they have to be long lasting and reliable. So that's where industrial Internet of Things is different from Internet of Things. So industrial Internet of Things is basically an artificially intelligent system which can take most of its decisions on its own and without any human interaction. So to what then does the term industrial AI refer? We know the AI, so basically is artificial intelligence. But what does industrial AI, why we say it's industrial? So same like industrial Internet of Things. Industrial AI is slightly different because our requirements and our expectations are different. So certainly the word industrial has certain immediate connotations. So when we say industrial, mostly to our mind, it comes manufacturing or heavy industry. But that's not always the case. Industry can be any industry. It doesn't need to be just the manufacturing or heavy industry. It can be any other type of industry, pharmaceuticals or medical devices manufacturing or some smaller industry. So to limit our scope to just those industries would be to miss the less obvious connections between a broad set of related use cases. So we define industrial AI as any application of AI relating to the physical operations or systems of an enterprise. So physical operation, it can be just like loading, unloading, and controlling the conveyors, controlling the reaction chambers or other type of industrial applications, or it can be just a system of enterprise, so controlling the logistics, controlling the resources. So industrial AI is focused on helping an enterprise monitor, optimize, or control the behavior of these operations and systems to improve their efficiency and performance. So whichever way we can improve efficiency and performance by using those techniques, so that is then called industrial AI. So industrial AI, any AI relating to physical operations and systems of an enterprise, uh, that is then called industrial AI. So can be physical operations like logistics, asset management and maintenance, production facilities and assembling facilities, or it can be physical systems like sensors and devices, machine tools, industrial robots, the whole system of robots, and a complete production line. So we can control all of that by using industrial AI. So how is industrial AI different then from this normal business AI? Because the stakes are much higher. That's the major difference. Uh, when we say stakes are much higher, obviously in industry, it's a lot more at stake. So we need to ensure that this whatever AI system we implement has to be very, very reliable, high quality, and long lasting. So because there is like a lot of investment in terms of infrastructure, in terms of capital and all other equipment and machines. So that's why that industrial AI is a little bit different. So in normal business application, the primary domain is digital. Like if you have AI based app, which is collecting just data about your location, your communication with your friends, that's just digital, right? But in industrial AI, it's not just digital, it's also the physical system which is at stake. So use cases in business applications are marketing and sales, customer service, HR, and other analytics. But in industrial AI, there are several other physical and digital use cases like predictive maintenance and supply chain management, fleet logistics and routing, quality control, packaging, HVAC, um, automation, fault detection, alarms management, and the data sources are obviously then different. In industry, we use SCADA systems, we use IoT sensors, and some enterprise data sources. The delivery models are pretty much similar. Like in business, we use web, mobile, desktop. But in industry, we have several other options. Like we have industrial robots and connected devices, intelligent systems. So consider an example of a predictive maintenance system monitoring performance of an aircraft engine. So if an analytical system on a plane determines an engine is faulty, so we have to send specialist technicians and engineers to remove and repair the faulty part. So imagine if the AI system for such application was not 100% accurate and the fault was a false alarm. So all that what you have done, the dispatch of specialist technicians and engineers is a waste, right? So if they discover there wasn't any problem. So that's why industrial AI has to be very, very accurate and reliable. So it's not just the cost of technicians and engineers in this case. Um, a loaner engine must be provided as well so that the airline can keep flight operations while you repair the other one. So the entire deal can easily surpass $200,000. So that's why I said there's much, and the stakes are much higher. So industrial AI this presents several challenges that differentiate it from consumer and business applications of AI. So that includes data acquisition and storage. So that is one of the most important activity with AI that we can um, acquire the useful data and store it. These days we have cloud storages, and so then it is very useful that we can store data in a structured format and in a secure way. The training challenges is another thing because conventionally the workforce working in industry, they are not very trained in AI systems, so that is a challenge in transformation. How do we plan the training activities for the existing staff? So then there are some additional costs in terms of testing, because industrial application requires some testing, and it can be complicated as compared to business applications. High regulatory requirements because the industry need to follow certain regulations and standards. So they can be also challenging, high cost of failure and change, large stage spaces and cost of talent. Obviously, you need specialists for AI working in the industry now, which wasn't a requirement before. So that is an additional cost. So that's is different from business applications because in business application you don't need dedicated people all the time. So it is like on need-based basis. So enterprise AI applications landscape. So in enterprise, obviously, then is about monitoring and control. Like I said before, large or enterprises, they have some control centers in the middle of the city or in somewhere urban areas, but their sites can be remote and they can just remotely monitor and control and optimize solutions. So that's where AI is very useful. So you can monitor the quality, monitor the productions, and any supply chain risk management, and optimize the process planning, scheduling, fleet management. And with the control systems, we can obviously control the factory automation, and we can have autonomous vehicles or autonomous robots working at plant site. And similarly, for power application, we have nowadays smart grids. So smart grids are becoming popular as well because they are very, very useful for modern power systems. So all that is the applications landscape for AI in enterprise level. So some applications of industrial AI which are widely used, cobots working with humans. So you must have heard of cobots. They are called collaborative robots. So they frequently work alongside human workers, functioning as an extra set of hands. So autonomous robots, we know they can perform repeated tasks like the ones we have in assembling plants like vehicle. I think all of the vehicle manufacturers these days, they have shifted to AI or robotics. So most of their process is now controlled by robots. So all the assembling tasks, because they are more repetitive. So cobots are one step ahead than those autonomous robots. So cobots are capable of learning various tasks. So they work with humans, and they learn from what humans are doing, and then they implement that. So they can detect and avoid obstacles, and this agility and spatial awareness allows them to work alongside and with human workers. So that is obviously because of the artificial intelligence they have. So another very useful application for industry is digital twinning. Digital twinning is a relatively new term, but it is becoming very uh, popular because of the advantages it has. So in industry, we always prefer doing things that have less consequences, right? So digital twin offer that possibility, means that capability that we can perform certain tasks and do some simulations without interacting with the actual system. So then we can avoid any consequences. So if we do something wrong, or if we want to like bring some innovation within our system, so we can use these digital twins to see and validate those new additions, that they can work properly or not, so without damaging the actual system. So digital twin, there are major companies, they have already started doing digital twinning, like Siemens has introduced digital twin in TIA portal, and GE and all other companies, they are doing digital twinning for their products. So when you use their products, you can have a digital twin. So a digital twin is just a virtual model of a physical object that receives information about its physical counterpart through the latest smart sensors. So it's like a real-time um, data acquisition system. So when the physical system is running, it keeps sending the real-time data to its virtual part, and then virtual part learns from their data by using AI and other technologies, and then it becomes a twin of that physical part. So companies can monitor an object throughout its life cycle and get critical alerts such as need for inspection and maintenance. So it's like having a virtual system in your computer or in your facility without having any physical part. So you are actually interacting virtually with your physical system. Predictive maintenance, as I said earlier, is another very interesting application of AI because it improves safety and lowers cost. As the name says, it's predictive maintenance. So based on the data we are collecting from all these smart devices and machines, then we can use AI, means artificial intelligence and those algorithms to process that data. And that can give us some analytics about the condition of the plant, condition of the machines and devices, so that we can predict when do we need maintenance. So it obviously becomes very efficient to do maintenance in that way, that you do maintenance whenever is required. So whenever you predict the maintenance, so you already know that something will need maintenance in 3 months time. So it not just improves safety, but also improves your planning, because you can plan your resources if you need someone to do that kind of maintenance, or you have your schedule ready. So it lowers costs because you essentially reduce the failures. So if you maintain your system before it starts going bad, obviously you will reduce the failures. So failures obviously come at a cost. Uh, Anytime if it's a large organization or large system, um, even a few hours failure can cost a lot of money because you're not producing anything. So that's where predictive maintenance is proving very useful. And machine learning algorithms can be used for predicting demand. Unlike in the past, where the companies used to produce everything in bulk and then ended up having a lot of stock, which sits there, and over the time it becomes a loss. So nowadays they can use these machine learning algorithms to predict the demand. So because they are collecting data about their sales, and then they can make decisions how much of something we should make so that we can fulfill the demand. So they don't make something over and not under as well. So um, then there is no shortage and no access. So it is a very useful technique, and it is becoming very popular as well. So there are wide applications. There are several other applications, and it's hard to mention all of them in this webinar because I want to talk to you about the regulatory frameworks as well, because it's a developing field. So there are some developments in the regulations and standards as well. So you should know by means of where to look for right information if you want to get more knowledge, or if you are going to implement one of such systems. So you should know which regulation will apply and where can I get guidelines. So other applications include lights out factories to save money. So lights out, we use this term, but it's not just lights out, means robots. If we don't have humans working on the site, obviously we don't need such lighting, and because robots, they can also work in the dark because they have these sensors and detectors and precision measurement devices, so they don't need light. So the term applies to everything else as well. Like if you have humans working on site, you need to provide right environmental conditions, air conditioning, and other facilities, lunch, and all that. So if you don't have humans on site, then you save a lot of money. That's why it's called lights out factories. So there are several factories which work on this principle. And then inventory management to prevent bottlenecks. Again, you can manage your inventory so you never run out of stock. And then AI to boost supply chain management, AI systems to detect errors, AI systems to help speed product development. So when the demand is high, obviously you need to produce more. So these artificial intelligence systems can make those decisions when to produce more, when to reduce the production. So there are certain trends driving AI advancement, and those are in terms of monitoring, optimization, and control. So monitoring provides situational and predictive awareness, and offers increased quality, reduced downtime, decreased stockouts, reduced risks, and it requires some smart devices and data, right? Similarly, optimization provides planning and decision support, and it offers greater efficiency, improved utilization, increased yields, and more effective designs. And it requires effective monitoring, because then we can use that data from monitoring to make optimization. And similarly, control provides automated response to environmental changes. So it makes decisions that can uh, control any deviations and control the parameters or the processes within certain range, so that we can achieve increased production and productivity, lower labor costs, and reduce wiring. Um, can It requires effective optimization systems. So these three are interlinked: the monitoring, optimization, and control. Okay, so what AI can do for you? There are limitless applications at the moment. So you can do smart manufacturing, Internet of Things, smart farming, smart transport, smart cities, disaster recovery. So these are some of these applications of AI, but there are tens or hundreds of different applications where you can use AI. So some important questions around AI. So just how worried should we be about killer robots? So that's a very old time question. Every time people ask about how the robots will take over and they become killer robots, and there have been several movies about this topic. Um, so it's not just about this question. There are several other questions which are very, very genuine questions, um, not just about the killer robots, but also about how are we going to use this technology, and who is going to provide guidance, who's going to say what is ethical, what is not ethical. So artificial intelligence is no match for natural stupidity. So the most of the risks are not from artificial intelligence itself, but they are from the people who are using artificial intelligence for certain applications. So the risks are associated with human intelligence rather than artificial intelligence. So AI is a new and fast changing field full of innovators and disruptors. So there are a number of points which must be dealt with. So that's why we need some kind of standards and regulations before it becomes widespread. So ethical and societal concerns such as safety of machines, working side by side with people in manufacturing plants. We need to ensure that humans are safe, and it's not that the machine will take over and kill the person, but if there is a fault in the machine, or if something goes wrong, or if the program is corrupted, or if someone hacks into the machine. So then this can be a problem. And then the overall safety of AI-enabled systems from a data perspective, how do you control the data flow? That is a very basic question. So who is responsible for making decisions and managing how such systems are developed? Do managers have enough of an understanding of the wider implications? Maybe not. So that's why we need someone to answer those questions. So before we get into it full on, so how can we unlock the AI promise? Given that AI data is at the intersection of many different fields, it is hugely important that a common framework is developed. So we need to come up with a common framework which can be interdisciplinary and can help us uh, make some ethical decisions and safe decisions. So AI technologies and their applications continue to grow and evolve. AI is now being deployed across almost every industry and sector, including transportation, healthcare, defense, finance, manufacturing. So, but what exactly are these technologies? So someone has to provide that reference that if you are going to use this technology in certain industry, this is what you need to be careful of. So how prevalent are they? And with AI developing so rapidly, how will international standards respond to these challenges? So like I was saying, it was just yesterday we were talking about Industry 4 and now we are talking about Industry 5. That's how quickly this technology is developing. So how is international standards organizations, how are they responding to these challenges, and how are we coping with such a dramatic change in this industry? So first of all, it's all about trust. Um, how do we ensure that, because it's a new technology, if the trust is lost, then it will be a big disaster. So we can't really implement this or can't fully benefit from this technology. So because AI has the potential to aid progress in everything from medical sphere to saving our planet, yet as the technology becomes more complex, questions of trust arise. So increased regulation has helped to rebuild this trust, but still there are gray areas, partially because of some organizations not acting as they should, right? So um, I didn't want to name anyone, but it's a very famous case. So that's why the US consumer regulator slammed $1 billion in fines because they didn't have those procedures and regulations in place which are useful, which are required actually. So how can we ensure AI is trustworthy without impeding its progress, without stopping, without any hindrance? So that obviously comes from the standards and the regulations. So key threats to AI trustworthiness are malicious use, obviously, first of all, and then personal data leaks, cyber security. So for example, a self-driving car that is involved in an accident could be hacked, and information related to liability can be meddled with. So a system that aggregates patient data and uses it to recommend treatments or make diagnosis could suffer errors or bugs that can result in disastrous outcomes, right? Or some results of a drug testing can have errors, so that can be a big disaster for humanity, right? So standards for AI should provide tools for the transparency and a common language so that everyone is aware of the requirement. And for this time is now. So we now have to work on it and decide whether to ethicize or not to ethicize, right? The later one is shouldn't be a question. We have to ethicize if we want to sustain, if we want to build a sustainable um, future, then obviously we need to go for ethical systems and ethical technologies. So ethical decision making isn't just another form of problem solving. Is a lot more to do. So AI presents new and unique challenges to ethics as artificial intelligence grows in capability and influence. So experts are treating uncharted territory to develop these international standards for ethical AI, addressing its challenges from the onset. So from the beginning, if we have control over such ethical problems and other problems, so then obviously we can achieve more with these technologies. So there is a combined effort going on with ISO, IEC, IEEE. You must know these standard bodies. They are the uh, worldwide organizations that provide standards for all other technologies. So they have come together to form this subcommittee, which is called SC42. So SC42 is doing all that work which is required to um, provide these standards in AI domain. So there are actually 5 work groups under SC42. So each work group has its own task. Like for trustworthiness, we have work group 3. So many these developments in terms of trustworthiness are done by this work group 3. So international standards could play a role in identifying the ethical issues and provide the necessary framework to address them. ISO will also need to adopt and innovate to meet future challenges. So that's why they are coming forward and collaborating with others to form such ecosystem. So SC42 is actually an ecosystem. It's not just a document. It's an ecosystem which represents different domains, right? So example of non-technical trends and requirements like application domain requirements, regulatory and policy requirements, emerging societal requirements, like the societal requirements have completely changed with the introduction of these technologies. So we have to clearly change our rules and regulations. So business requirements, KPIs, and in terms of SC42 ecosystem, assimilating requirements for context of use of AI, big data, and analytics. And the deliverables are obviously then foundation concepts, like you understand the foundations of the technology. And then you have some certain data standards, because data is the key in artificial intelligence, and reference architectures, use cases, frameworks, guidance, and interoperability, because AI is multidisciplinary. So we need to have some framework for interoperability as well. So SC42 has provided and is working on those foundation standards. There are some application standards and there are some proprietary solutions. There are some open source projects going on. So hopefully in near future, we'll have those frameworks. So foundational standards, as I said, they are about the understanding of the foundation of technology. And there are some other work groups, like for big data, we have WG2, and trustworthiness, WG3, use cases and applications, there's work group 4, and the computational approaches and computational characteristics of AI system, we have work group 5. So they are all working in collaboration so that we can come up with the with something which is foundational and can be implemented for future requirements. So in terms of trustworthiness, SC42 is developing a suite of standards that provides an overview of emerging issues like trustworthiness, robustness, and bias. So when we talk about trustworthiness, you can't ignore bias in AI. So because everything is according to the data, and data can be sometimes biased. So there can be some biasness in AI, means um, you can implement it in a way which can produce some bias, right? So that's why we need such standard which can obviously overlook those points and those challenges. And ethical aspects and societal considerations, obviously, if we have monitoring and control of everything, that includes humans as well, that includes our society as well. So how do we overcome such challenges um, that cannot be misused? So new requirements around ethical and societal concerns have emerged with recent information technologies, and AI is no exception, right? Is if you're there are some new requirements in terms of mobile use or in terms of all the social media usages. So AI is same. Industrial AI is also similar, because in industry, it's not just about controlling machines and monitoring machines. Nowadays, we have these employee checks and all that. So SC42 is addressing these concerns across the board in its deliverables. For example, ethical and societal concerns around use cases, as well as specifically by having deliverables that tie these requirements to technical standards being developed. So then it all it all becomes aligned. And data, as I said in the beginning, data is the backbone of industrial automation and AI. Without data, we can't do any of those. So data is very important, but how do you protect that data? So data security is very important. And how do you make sure that data is accurate and reliable? So that whole thing is then called data ecosystem, because there are several processes through which data passes, or several processes exchanging data, and then it goes to several different locations. So need to do a lot in terms of data ecosystem. So within its areas of focus, SC42 is looking at data ecosystem and has launched a 4-part series on data quality for machine learning and analytics. So this complements the work in progress on big data analytics, as well as the published work on big data. So there's a lot about quality of data. And then governance implications, like I said, so management and governance has some requirements as well, and some obligations too, like if they have access to all that data and all that information, how should they behave in that position, right? So standard is again, SC42 is aimed at executives or boards looking to deploy the technology, and it addresses the issues with that perspective. So then those board and the executives also have some responsibilities. So in terms of computation, C42 is examining the computational aspects associated with knowledge management, which is focused on front end of the process through to the existing computational techniques used in AI system, and also emerging needs. So this type of work will ensure that AI system will factor in practical needs of application domains, such as smart manufacturing. If you're talking about smart manufacturing, how will you achieve the computational requirements? So what type of systems you will need for such requirements? So that all it means we can get guidance from SC42's documentation. And then management system standard, SC42 is leveraging the management system standard approach and has started working on ISO 42001 for AI management system. So there has been a management standard. I think everybody must know that ISO 9001 is our management standard, which we use for all other stuff. But this new standard 42001 then is focused on AI management systems. Okay, so the concluding remarks, some key points like the ability to provide insights is at the core of digital transformation and the emerging applications and services powering it. So we can't overlook any of these. So IT systems and technologies such as AI and big data are key enablers. So that's why we have such standards like SC42. So SC42 is developing in this area, and these standards are crucial to removing barriers to adoption. So means some industries are still hesitant to go for artificial intelligence because they are obviously afraid of so many different questions. So nonetheless, the standards and technologies will have to be used in concert with operational technology standards. So we can't just have a standard which is standalone. It has to be implemented with other operational technology standards which we already have in place. So SC42's approach to consider the entire ecosystem and develop horizontal standards allows for a platform that makes such collaboration easier. So that's why this SC42 subcommittee has a lot to work on, because if we are talking about these horizontal standards, means which can have an interaction with operational as well as AI technologies. So it has to be very, very efficient, right? Okay, so that's all from me. I will pass on to Riley.
Thanks, Imtiaz. Appreciate that. That was a great presentation, and there was a lot of interaction in the chat box, which is good, and a few questions came through during the presentation. But we will have a short Q&A session shortly. Just before that, though, I'll just run over our upcoming webinars. So if anyone's interested in attending one of our upcoming technical webinars, we do have some on the website. So if you just go to our events page, you'll see all of our upcoming webinars. I would like to mention, especially for anyone that is located in South Africa, we are actually holding a couple of physical face-to-face seminars that will be run by our Dean of Engineering at EIT, and it'll be kind of like a presentation and networking session. It runs for about an hour and a half. There's two seminars, one in Midrand and one in Cape Town. So if anyone's in South Africa, I'd really recommend to have a look at those as well. But otherwise, we have these webinars coming up. So voltage stability and islanding control in microgrids is in a couple of weeks' time, and the week following is an introduction to calibration temperature sensors. So just have a look on our events page for those and register from there. And our upcoming courses, so basically the Professional Certificate of Competency courses that I mentioned at the start of the webinar, there are short courses. They run throughout the year, and that's the same for our diploma and advanced diploma programs. So the intakes are at various times throughout the year. Some courses have multiple intakes, some courses will only have one intake per year. We have undergraduate certificates, Bachelor of Science degrees starting on the 25th of July, as well as the Doctor of Engineering. And on June, our graduate certificates and Master of Engineering degrees are starting. And then for anyone who's interested in studying on campus in Australia, at one of our two campuses, either in Perth or Melbourne, we have our on-campus Bachelor's, Master's and Doctor of Engineering program starting on the 1st of August. And if anyone's looking for travel information, please refer to the relevant government websites. I would recommend you all to have a look at our schedule page, which shows all of our courses and all of our intakes upcoming. So please check that out when you can. Now, for the certificate of attendance, so as mentioned, we do provide a free certificate of attendance for this session. So basically, you just, if you've got your smartphone there, just get your the camera out and you can scan the code, the QR code on the screen there, or you can click the link that I'm posting in the chat box now. That QR code link that I've just posted in the chat box, you can click that link and it will take you to a short form or survey that you need to complete in order to receive a certificate. And I will be sending out the certificates tomorrow. So yeah, so please look out for those just in your inbox or your junk email folders. Yeah, I'll just leave that slide up for a few more seconds in case anyone wants to scan the QR code or click the link in the chat box. Okay, so we will have a Q&A. So basically, if anyone still has any time to stick around, and if anyone wants to ask any questions to Dr. Imtiaz or myself, please do so. Please put your question in the chat box, and we'll try and respond to you within the next few minutes. And I'll leave the contact details slide up there, but yeah, in case you have to go, thank you for attending and hope you have a good day. But otherwise, stick around for the Q&A. If you've got any questions, please put them in the chat box. We've got a question from Lanray. Imtiaz, what programming language do you consider most relevant to AI applications to chemical systems?
Yes, thanks, Riley. That's a very good question, actually. Very important in terms of getting AI ready. So there are several languages, and it's hard to say that there is one language which you can learn and you become an AI expert in any application. But obviously there are some languages that are fundamentally important, like C language and Python. So Python has shown a lot of potential because of the ease of its application. So Python is being used in data science, and there are several libraries already developed in terms of data science, so they can be implemented in several other applications. So I would highly recommend Python for AI and machine learning. And obviously C language is also, it has also its own importance. Not saying that C is not important. But if you would like an application based language, so Python is the best.
Thanks, Imtiaz.
And we have introduced a unit in, sorry to cut you off, Riley.
That's okay.
So EIT has been working on keeping up to the changes in technology. So I would like to tell you that EIT has recently done a course reform, and it has introduced a lot of topics about artificial intelligence, machine learning, and data science in their programs about industrial automation, electrical engineering. So um, it is very good to see EIT providing such opportunities which are useful for future.
Thanks, Imtiaz. We have another question from Gabriel. Do you have any comments about how AI might affect urban planning?
Yeah, so when we talk about smart cities, that is actually about urban planning, not just connecting devices, but also helps us in planning the resources, planning the housing, planning the facilities and infrastructure. So there is a lot happening. Actually, there is a campaign I know in Perth. I forgot the exact name, but it is about making Perth a smart city. So it is all about managing your resources, managing your facilities and infrastructure, how smartly we can um, use those resources and infrastructure so that our city can become smart.
Thanks, Imtiaz. We have another question. Is SCADA an example of digital twins?
Yeah, so digital twin, as I said, it is already in application now. There are some systems which can um, just use the vendor specific software. So to produce the digital twins, like I mentioned, Siemens provides that opportunity by using their TIA portal. GE has these digital twins of their wind turbines, and there are several other companies providing that opportunity. But obviously, if you are a developer, then there are endless opportunities if you can develop such software so that can provide digital twinning. That will be last time I was in a meeting, there were people talking about using digital twinning for housing now. So, which can be very, very effective, obviously, because it essentially provides the customer or the clients a virtual feeling of the actual house, when their house will be built. So there are like different domains and different applications of digital twinning.
Thanks, Imtiaz. Uh, and please note, everyone, I will be sending out an email tomorrow with the PDF slides and a link to the video recording of this webinar. And if you'd like the link to the certificate of attendance, I'll post that in the chat box again. We've got a
So
couple
I
more
would like to answer.
questions. Yeah,
Sorry,
go
I
ahead.
would like to answer one a generic question which comes to everyone's mind, and some students already asked that. I wanted to explain the in my introduction, but it went out of my mind. So one of the basic purpose of choosing this topic was to actually give our students and the next generation this clarity about what is going to happen, because there is a lot of scare that if AI comes in and robots take over, where will human work? Where will humans go? And there will be unemployment. That's not the case. So that's why I wanted to do this webinar so that you can understand where you can fit in this new industry. So there are a lot of regulatory compliance opportunities, and then there are a lot of programming automation opportunities. So it's just that how well you train yourself for future uh, that matters. So I would recommend to look at again those courses which EIT is offering and other universities are offering, which are relevant to the implementation. Obviously, we need humans to implement those machine learning and train the machines, and then obviously supervise those robotics, and also do the data analysis. We can't leave everything up to the machines, right? So still there will be a lot of opportunities. There might be a diversion, like we need to choose a slightly different um, employment stream, but or skill stream, but there will be a lot of opportunities. Actually, I see um, a growth in employment opportunities with the implementation of new technologies, like we are seeing already in Australia with the introduction of these renewable energy. Even if they are, most of the systems are smart systems, smart grids, and they can work on their own, but still it's a new business stream. A lot of people got employments. Actually, we have shortage these days. So yeah, being optimistic, I would say you just look at where would you uh, want yourself and in this field, like then you go for those skills. Like someone asked about programming language, so if you can become good at that. Similarly, automation, in industrial automation, there are a lot of aspects where we still need humans. So just train yourself for those new technologies.
Thanks, Imtiaz. I think we'll just do one more question. I believe that's all we have time for. But this question was, what are the typical competencies needed for machine learning and artificial intelligence application development?
Sorry, can you repeat, please?
Yeah. So the question was, what are the typical competencies needed for machine learning and artificial intelligence application development?
Yeah, that depends upon the application of that AI. If obviously every industry has the unique requirements, but in generic, if you want to learn or get competent in machine learning, then obviously you need to be good in programming, coding, and also have understanding of the electronics and automation. So I think that will be good for some competency. And obviously specialization then comes from focusing on one area of application.
Great. Thanks, Imtiaz. And yeah, I'm sorry to everyone else. Like, there's limited time, but you can send any questions through to my email address, which is on the screen, webinars@eit.edu.au. I'll be more than happy to respond to your email or forward it on. Thank you very much for your time today. I will send out the email tomorrow with the PDF slides and the link to the video recording. And if anyone wants to receive a certificate of attendance, they can follow the link in the chat box. Thank you very much and have a great day wherever you are. And thanks again, Dr. Imtiaz, for your time and presenting.
My pleasure. Thanks, Riley. Thank you for organizing this. And thanks, everyone, for listening. Take care. Stay safe. Goodbye.
Thank you. All right. Bye-bye.